Hey guys, and welcome back. So now we're going to create the volume collision for the RBD, and I have a trick that I want to explain in this video. If we go through this anim, you will see that some part of the building, they never transform, they never move. And we want to know that information because right now we're going to be creating SDF for everything. And this SDF is going to change every frame. Well, if we have certain parts that never moved throughout the entire sim, there is no reason for us to make them change every frame. So we want to analyze the sim and see if there is any pieces that didn't move at all from frame 1 all the way to the end. And then we're going to separate them into I became active or not. And then one is going to have a static SDF and then the other is going to have a changing SDF. The other thing that we need to do is, right now the pieces are flying far off, they are covering a huge space, and based on all the shots we're not gonna see this, for example, or we're not gonna see other pieces that are very far away from the scene interacting or having collision with the particles. So we need to isolate which one have traveled so far, and those that did were probably shot out really fast anyway for them to get this far. So we want to use the distance and basically narrow down everything that is close to the main building. Everything else we don't have to worry about. And the reason for this is because we want to reduce the domain of the science distance field as much as we can, because it's a voxel based. If we have everything compact into a small area and then one object that is very far off, the domain has to expand to encompass everything. So we want to localize and to make it very efficient. Okay, let's implement the system to find out which is active and which is not. Now I have the RBD objects here, and what I'm going to do is let's see if we have a rest attribute. We do not have a rest attribute, so I'm going to use a time shift, and let's delete this and set it to frame 1, and this is going to be my rest position. So now we have a rest attribute. And what I'm going to do is I'm going to use a time shift, and this has 240 frames. That's how long the sim is. I'm going to move to 240. I'm going to delete that. I'm going to use a point VOP. Okay, and I'm going to import the rest attribute. So bind rest attribute, it's a vector. And then I'm going to subtract the current position from the rest and plug that into the color. Sorry, we need to compute the length of that. And if the point has moved, we will see that reflected in the colors. If the point didn't move or moved just a tiny bit, we will see that reflected in the colors as well. So what we can do is we can plug in a ramp here. And tweak the ramp so that everything that moved or didn't move we can isolate. And now the things that are colored in black probably didn't move or moved just a tiny bit. That doesn't have a huge impact, and we don't have to keep updating the SDF for that. And what we can do now is we can create an attribute called moved or move, for example, and say it's an integer, it's equal to 1, but if the color dot x is less than, let's say, 0.2, this move attribute is actually 0. Okay, and let's isolate based on that. So at move equal 1. So this is the parts that didn't move, and this is the part that moved. But we don't care about it being here. We want to transfer this back into the geometry. So let's do that. We have a name attribute. And let's see if this inherits that by default. No, it does not. So let's do it here. And this way we don't even have to use a transform on all of them. So I'm going to attribute promote the name because it's a primitive attribute. I'm going to promote it to a point attribute. I don't want to delete the original. And I'm going to use a copy attribute or attribute copy. And what I want to do is I want to copy the move attribute, matching by the name attribute. And let's use this. And now I want to isolate this. So those are the points that didn't move. And now I can isolate this part here. And delete non-selected. And let's connect this. And that's everything that moved. And we're gonna generate an SDF for this. But right now it's too big. We don't want this much. Okay, so I'm gonna do one more thing. With this time shift thing, I'm gonna use a group node. I'm gonna group points based on a bounding box that I'm gonna set by hand. And I'm gonna narrow it so it's not too far. Something like that. And I'm doing this in the last frame. Remember, we're not doing it in the first frame. And I'm gonna say let's create an attribute, call this inside, I at inside equals 0, and then I'm going to call this group inside as well, copy this node, and then change the inside attribute to the points that are inside only. I'm going to use this info as well, and I need the move and the inside. So I copied that back into onto the points, and now I can add another delete. So here, yep. So for the things that moved, it's a bit slow because the geometry is very heavy. Let's put down a blast node. So inside equal 1, it's a point attribute. And delete non-selected. And that's the geometry centralized. So let's connect this to the transform pieces and move to the last frame. We should see, yep, we should see only the points in the center. And so what we did is we took all the points, we selected an area where it says, okay, these are the pieces I care about. We copied this information, the I care about pieces, onto the geometry, and then we deleted that. We deleted everything else. We just kept that core. Here it looks messy because we don't know what's gonna happen, but then once we start transforming everything, it's gonna look right. So we have localized what's happening. Yeah, the viewport is not the best. So that's the area we care about. And then I'm going to use a VDB from Polygon. And just to clarify, I wanted this so that I don't create a VDB that is localized and then has a point here, because we have to encompass all of that. So let's set this to 1. Or maybe 2, so that it's faster. And that's our SDF. It's very low res at the moment, so let's lower it. And let me check one quick thing. And this is, again, it's not very high res, but I'm gonna load in the original one so I don't have to fill up the memory. And this is the SDF. And if we play through, you can see it's pretty fast to load. It's not very high res, but it's enough for the system to work. And this one, I didn't delete the inactive pieces, I just isolated by area, but we should isolate the inactive versus inactive. And I still have one more advanced technique for working with this, and we're going to explore with the volumes next week. But for now, this is what we're going to be using with particles. And I'm also sampling the velocity field. So we have to make sure that the pieces have the velocity attribute on them, and then we're going to sample that in SDF, cache it to disk,